Hey guys, this is Mr. Waite. Today I'm going to talk to you for a few minutes about the expanded algorithm for multiplication. Specifically, we're going to talk about solving a 2-digit by 1-digit and 3-digit by 1-digit multiplication problems. We've been doing this week in class. We've also been looking at some 2 by 2 multiplication problems. I will make a separate little example slash how-to video for 2 by 2 problems because I didn't want this one to get too long. A quick PSA on why we use this expanded algorithm to solve multiplication problems. I know that many of you guys, parents, are maybe used to a different sort of, they call it like the old school method for solving multiplication, and which we call the standard algorithm. And so number one, I'll say that we're still going to teach that method, and your student can still use that method till the end of time if that's what they end up really liking. But I think it's important, especially for high achieving math students, to be exposed to as much as they can when it comes to problem solving, and to be shown different ways to think about the same problem, and even a problem that has an answer they ultimately might know. Sometimes the more valuable thing they can take away from working out a problem, whether it's a multiplication problem or something else, sometimes the most valuable thing they can take away from it is the process by which they found the answer, not just the answer itself, right? Sort of the mental gymnastics or the problem solving thinking that they did to find the solution can be more valuable for them than the answer. That was a little rambly, I'm sorry, but here are some examples of a 2 by 1 and a 3 by 1 multiplication problem using the expanded algorithm. I'll also show you a couple array pictures since we've been using those as well, and it really sort of demonstrates that algorithm that we're trying today.
The first thing we need to remember in order to use the expanded algorithm for multiplication is we need to know our expanded form. And the expanded form of a number is just a number written out as the sum of its place values. In other words, we break it apart into each of its places. So a number like 43 is the same as 40 plus 3. Or a number like 922 is the same as 900 plus 20 plus 2. I think you guys have the idea. And the way we're going to use this to help us with our expanded algorithm is like this. Let's say that we have a multiplication problem like 5 times 43. I think 43 is my first example. We're just going to use what we know about our expanded form to break apart our 43. We're going to break apart that factor into its parts. So we're going to say 5 times 43 is the same as 5 times 40 plus 3. Our rules for math tell us that when we multiply this, we're going to be multiplying 5 times 40 and then 5 times 3, and we can add those two parts together to get our final product. So I don't make the students write those steps out every time. They can just show it like this. We have a number like 43. We're going to set it up vertically, 43 times 5, like that. And we're going to do the same thing as I just showed you. 5 times 3 is our first problem that we're going to solve. That gives us 15. This is called a partial product because it's part of our product, it's part of our answer, but it's not our final answer. After we've done 5 times 3 to get 15, we're going to do 5 times 4. But remember that this 4 is actually in the tens place, so it's really a 40. So 5 times 40 is going to give us 200. And that's mental math that the kids can do. They would just think for that problem, well, I know 5 times 4 is 20, so 5 times 40 with an extra 0 placeholder is going to be 200. We have our two partial products, and we just add them together to get our final product. Just like that. Here is another example. I'll do another 2 by 1 example, and then I'll show you a 3 by 1. So let's say I have a number like 54 times 8. I'm using my finger, by the way. I lost my stylus, so if that's a little sloppy, I apologize. And again, we know that 54 is going to break into 50 and 4. So we're going to multiply each one individually, each digit individually. 8 times 4 is going to give me a partial product of 32. Okay. And 8 times 50, remember that's in the tens place, 8 times 50 is going to give me a partial product of 400 because 8 times 5 is 40. So 8 times 50 is going to be 400. I add my partial products and I get my final product of 432. Okay, for a 3 by 1 problem, it's going to be the same thing. We're just going to extend it one more step. With something like this. 326 times 5. Okay, so again, I know that 326 really is going to break apart into 300 plus 20 plus 6, so I'm going to multiply each of those parts individually. 5 times 6 gives me a partial product of 30. I'll try and squeeze this in. I feel like it's going to be tight. 5 times 20 is going to give me a partial product of 100. And 5 times 300 is going to give me a partial product of 1,500. And then I just add up my 3 parts. I get a total or a final product of 1,630. I hope that makes sense, guys. I think I said in the introduction that I was going to show some array pictures to demonstrate this as well, and I'm just going to save that for another video. Hopefully this gives you some insight as to how we use the expanded algorithm to solve these 2 by 1 and 3 by 1 multiplication problems. I also mentioned I'll do a separate video showing some 2 by 2 examples because that's slightly different. Okay.